Welcome back from the ad break, and let's continue with our lesson. So we were busy with multiplication of those monomials and integers with binomials. But now we are going to look at a non-constant binomial. So remember, we need to make sure that each term of the binomial multiplies with the monomial, and then we are going to apply the exponent laws when we are multiplying those variables. So remember, when we are working with exponents, if they have when we're working with powers of the same base, they have the same base, then we add those exponents. Let's look at this example. So we have the 5x squared multiplied by 7x minus 3. Remember, each term in the binomial must multiply with the monomial. So we are going to say 5 multiplied by 7, that is a 35. Then we are going to multiply the variables as well. We have an x squared multiplied by an x. Remember that x has an exponent 1. And what happens if the base is the same? Yes, we are going to add the exponents. And then that is going to give us that 35x, and as an exponent 2 plus 1. Because remember, the same base, we add the exponents. Then we are subtracting in this binomial. We are going to multiply now the 5x squared with the 3. So 5 multiplied by 3 is 15. And because there is no other variable, we are going to write that variable as it is. So what is going to be our final answer here? We have 35x cubed, which comes from the 2 plus 1. Then we are subtracting 15x squared. Let's look at when we are multiplying trinomials. So when we are multiplying a constant monomial with a trinomial, we need to make sure that each term in the trinomial multiplies with the monomial, just like we did with the binomials, but now we have 3 terms. So we have 4 multiplied by 2x squared minus 7x plus 1. Remember, in the bracket, we have a trinomial because it has 3 terms. So we need to make sure that each of those terms are going to multiply with that 4. So 4 multiplied by 2, that is 8. And since as well there are no other variables, we are going to write those variables as they are. 4 multiplied by a 7, and remember, we are subtracting here. So 4 multiplied by that 7 is 28. And we are going to write the variable as it is. Then we are adding, and we have a 4 multiplied by 1, that is going to give us a 4. So that is going to be our final answer. What about if we are multiplying a trinomial with a non-constant monomial? Again, we need to make sure that each term in the trinomial multiplies with that monomial. And of course, remember those exponent laws when we are multiplying those variables. So we are going to now multiply negative 3 with the 8. Now negative 3 multiplied by 8 is a negative 24. Then we are going to multiply those variables together, and as we can see, they have the same base. So what does this mean? It means we add the exponents. That will be a 1 plus 2. Remember, where does that 1 come from? It comes from that exponent there, or that power there. Then we are going to multiply the negative 3 with the 9. So we are adding in this bracket, and when we say negative 3 multiplied by 9, that will give us a negative 27. And of course, that is going to be, we're going to multiply the variables as well, and because they have the same base, we are going to add the exponents. That will be a 1 plus 1 because the exponent there is also a 1. Then we are subtracting here. We are going to now multiply the 3 with the 5. So a negative 3 multiplied by 5 again is going to be a negative 15. So we have multiplied each term in the trinomial with the monomial. Now, let's simplify our answer. We are going to have a negative 24, and here we have an x cubed because of that 1 plus 2. Then we are going to be adding this negative number, which is the same as subtracting its additive inverse. So that is going to be minus 27x squared. And again, we are subtracting a negative number, which is the same as adding its additive inverse. So we are going to add our 15. And that is our final answer. Let's move on to the last concept, or just as a reminder, we remember that if the powers have the same base, we of course add the exponents. Let's go on to the last concept in our concept map, and that is the division of polynomials. Now, firstly, we are going to divide monomials by a constant monomial. So we're going to start with dividing our monomials with a constant monomial, which of course we know are the integers. And when we do that, then we divide the integers together and leave the variables as they are. So let's simplify the following expression. We have the 12k divided by 3. So we are going to divide the integers together. That is 12 divided by 3. Now what is 12 divided by 3? Yes, 12 divided by 3 is 4, and we are going to write that variable as it is. What about the next one here? We have 32p exponent 4 divided by 4. Now remember, this expression can come presented as a fraction, because we know that when we are dividing, we are dealing with fractions. So this could be 32p exponent 4 divided by 4. Of course, these mean the same thing. So what is our answer going to be here? Well, we are going to divide those integers. So what is 32 divided by 4? That is going to be an 8. And of course, we're going to write that variable as it is. But now what happens when we are working with a non-constant monomial? So when we divide a monomial by a non-constant monomial, then we are going to divide the integers together. Then we are going to divide the variables together, of course, remembering our exponent laws, that when we divide powers of the same base, then we subtract those exponents. So let's look at these examples. Let's simplify the following expressions. So we have there 28x divided by 4x. So this is going to be us. Now we're going to divide the integers first. So what is 28 divided by 4? Well, 28 divided by 4, yes, if you are thinking that it is 7, then you are absolutely correct. Then what are we going to do with those variables? Well, we are going to divide those variables. They each have an exponent of 1. So we are going to now subtract those exponents. And why are we subtracting? Because we are dividing powers of the same base. So the answer there is going to be a 7 and an x with an exponent of 0. But do you remember what anything to the exponent of 0 means? Yes, it means that it is going to be a 1. So here we have that 7, and that x exponent 0 is equals to 1. So because the exponent belongs to the x and not the 7, so we are only going to say x exponent 0 is equals to 1. And of course, what is our answer going to be there? Our answer is going to be 7, because 7 multiplied by 1 is 7. That second example there says 30p exponent 5 divided by 3p exponent 3. So that is going to be 30 divided by 3. We know that is 10. And because those powers have the same base, we are going to subtract those exponents. And that, of course, is going to be a 10p squared. And that is going to be our answer, because 5 minus 3 is equals to 2. So that was us dividing monomials by integers. Let's check when we divide binomials. So when we divide a binomial or a trinomial by a constant monomial, then we are going to divide the integers together and the variables are going to stay as is. So now we are dividing binomials or trinomials. Let's start with the binomials. As an example here, we have 15x plus 20x squared divided by 5. Now, because this is a binomial, each of the terms in the binomial must divide by that 5. So that is going to be here 15x. It is going to divide by 5, and also the 20x squared is going to divide by 5. So each of the terms in the binomial must divide by 5. Now, what is 15 divided by 5? That is 3, and we're going to write the variable as it is because it is not dividing with anything. Then we are going to add this to 20 divided by 5, that is 4, and we are going to write the variables as they are. And that is our answer for that expression. Let's look at the second question here. Now we have been given a trinomial, and that trinomial is being divided by a constant monomial. So we have 18p squared minus 6x plus 27, and this is all divided by 3. So that trinomial there is being divided by 3. Remember, just like we did with the binomial, each of the terms of the trinomial must divide by 3. So we are going to say 18p squared divided by 3 minus 6x divided by 3 plus 27 divided by 3. And what is the answer going to be here? Well, 18 divided by 3 is 6, and we are going to keep that variable as it is. Then we are subtracting here. Then we have 6 divided by 3, that is 2, and we are going to keep that variable as it is. Then we have 27 divided by 3, and that is going to be a 9. And that is how we divide a trinomial with a constant monomial. Lastly, let's look at when we divide either a binomial or a trinomial by a non-constant monomial. And again, we are going to apply those exponent laws when we are dividing. Remember, when we are dividing powers of the same base, if the base is the same, we subtract those exponents. Let's look at an example. Now we have here 10t exponent 4 plus 14t exponent 5 divided by 2t exponent 3. Just like we did with when we were dividing with a constant monomial, we are going to do the same thing. Each of the terms of the binomial or the trinomial, they have to divide with that monomial. So this is going to be a 10t exponent 4 divided by 2t cubed, and we are adding here, and this is going to be a 14t exponent 5 divided by 2t cubed. So each of those terms are going to divide there. Then we have 10 divided by 2, that is 5. And because that is the same base for those powers, we're going to subtract the exponents. Now 4 minus 3, that is going to be a 1. So that is our answer there. And then we are adding here. So 14 divided by 2, that is 7. And we are going to subtract those exponents there because the base is the same. Now 5 minus 3 is 2. And that is our final answer there. Let's look at our last question, which is a trinomial being divided by a non-constant monomial. Remember, each of them must get that, that term that is being divided. 12d exponent 5 divided by 3d squared minus, because we are subtracting in our trinomial, 33d cubed divided by 3d squared. And lastly, we have a 6d squared divided by a 3d squared. So what is the answer going to be? What is 12 divided by 3? That is 4. And because those powers have the same base, we are going to subtract the exponents. So 5 minus 2 is going to be our 3. Then we are subtracting. 33 divided by 3 is 11. And those powers have the same base, so we are going to subtract the exponents. 3 minus 2 is 1. And lastly, we are adding here, and we have 6 divided by 3. 6 divided by 3 is 2. And because we are dividing these same powers, we can use that exponent, the exponent laws, where we are going to say 2 minus 2 is 0, which is going to give us 1 in the end. But we can also say that since as well we are dividing the same power with the exact same power, those are properties of 1, we know that that is going to be a 1. So what is our final answer there? Our final answer is 4d cubed minus 11d, and we know 2 multiplied by 1 is 2, so that is going to remain a 2. That is the end of our wonderful lesson. I hope you enjoyed it as much as I did. We hope to see you next time. Goodbye.